Understand the definition of the rate of consumption, disappearance of a reactant. In chemical kinetics, the rate of a reaction can be expressed in terms of the rate of change of concentration of any reactant or product, scaled by the reciprocal of its stoichiometric coefficient in the balanced chemical equation. Rate of reaction equals delta x over delta t equals 1 over 2 delta y over delta t. Examine the stoichiometry of the balanced chemical equation. The reaction equation is x plus 2y gives xy2. The coefficient of x is 1. The coefficient of y is 2. This means that for every 1 mole of x that is consumed, exactly 2 moles of y must be consumed in the same time interval. Formulate the mathematical relationship between the rates of consumption. Let the rate of disappearance, consumption, of x be defined as rate of consumption of x equals dx over dt. Let the rate of disappearance, consumption, of y be defined as rate of consumption of y equals dy over dt based on the stoichiometric coefficients. The rate of consumption of y is always twice the rate of consumption of x. dy over dt equals 2 times dx over dt. Apply this stoichiometry to trial 2. Stoichiometric relationships between rates of consumption are determined strictly by the balanced chemical equation and apply to any point in any trial of the reaction, regardless of the initial starting concentrations of the reactants. Therefore, in trial 2, y will be consumed twice as rapidly as x. Conclude the correct option. This identifies option D as the correct answer. The correct answer is option D. Why? Because the rate of disappearance will be double that of x.